We took out the accessory bag for this instrument. Open the accessory bag. There will be a copy in the accessory bag, our factory inspection report, and the instruction manual certificate. Then there will be a USB stick in this file list. This USB stick contains this instrument, complete computer operating software. And this is our tool: a hex wrench and screwdriver, and the instrument power cord, the communication line of the instrument, and this is a spare part of our furniture: silicone pad. And what about these two boards? Are a sample for tensile testing. And this was a model for that private experiment. Take this power cord out of the accessory box. Our power supply is 220 volts. The power port of the instrument is facing the plug here. Plug it in. Then the other end. It's plugged into our 220-volt power outlet. That's it. So we're going to show you a standalone operation of the instrument. First of all, we have an emergency switch here, and a power switch. Then if our emergency switch is pressed, let's press this power switch again. It won't be powered on. Then we need to turn this emergency switch on and off. Gently turn the knob clockwise. It will pop up. Then press the power switch again. At this time, the instrument will turn on. After power on, first, let's click on the settings interface. Then identify the type of experiment you want to do. We can click on this experiment type. Select the type of experiment you want to conduct. It's stretched, stripping hot air, and tearing for types. Then the unit is selected. We generally use N by default. It means cow. Then judge the weigh and return weigh. It has automatic modules here. Type in manual. We generally choose automatic by default. Then the preloading force is generally 0.1 N. Then the loading displacement is 0. Then we can change the experimental speed according to the standard. Standard above, if it is 200 millimeters per minute. So let's speed this up to 200. Then gauge setting. If the gauge distance is set, it is also selected according to the criteria. The standard above assumes a sign of 50. Then we choose 50. The width of the sample is 15 millimeters above the standard. Thickness. We need to enter the actual thickness according to the thickness of the sample. Then the fracture condition is 75%. Generally, no modification is required. The return velocity is after we have done the experiment. Furniture returns to the origin at a speed. You can also change it here. It's using 500 millimeters per minute. It's when we do the glass experiment. The actual glass position of your experiment is enough. So let's go back to the home page. Then click on the test interface. After returning to the test interface, first we need to confirm an origin of our furniture. So let's click the reset button first. Point OK. Return the furniture to its original position. Now our furniture, it has been reset to its original location. Click on the home page again and click Settings again if our label or after the parameters inside are changed. Suppose I change the gauge to 100. Then we go back to the home page. Test interface. To click again after the reset. Our furniture, he will regenerate those parameters set by your latest one, distance. So let me demonstrate now. After reset, the distance of our gauge distance, it's based on the distance from the latest parameter we set. Next we demonstrate sampling. Take out a sample that you need to test. And I'm going to take this stretch panel here and put it on top of this. Through this stretch, these slits of the cut are aligned, and we can stretch through the cracks in the cut. We stuck the knife in this gap. Just cut along the gap. This is a sample we cut out for a stretching experiment. We're going to demonstrate a prototype for this ripping experiment. First of all, we're going to put the template on top of this. When we cut, you need to cut this corner inside first. Then cut elsewhere. This is the shape of our private experiment. So here's the loading. First of all, the sample has to be naturally vertical. To center. Then tighten it when screwing upper furniture. Needless to say, it's very tight. Just tighten it. Then unscrew the furniture. After the sample is ready, we first count zeros. Then click Run again. After the experiment is over, we have here the number of times you did one experiment, and the maximum force, mean force, tensile strength, and other parameters. Then we're going to look at the query report. First, click on the home page. Click to report again. There will be a record of the experiments we did here. Let's say we failed one of our experiments. We can delete it separately. After deleting, we need to cut another set of samples. Do a new set of experiments. Delete separately. After confirming this report, we have a reporting setup. What about the report settings? There are execution standards, experimental environment, a message on the header of the report. We can fill it in according to the actual situation. After confirming our report settings, then we click Print Report. And then we did this set of experiments. We need to count, except for records. If we don't click Clear Record, then the results of our experiment will keep stacking. If you have a few samples, the printed result is also different. So every time we did a set of experiments, we need to clear the record. Click OK and return to the home page. Click the test interface again. At this time, we can see that the number of experiments returns to 0. After zeroing, then you can test samples of the next variety. So we're going to go ahead and test the tare operation. First, we click on the home page. Click Settings again. Select the tare test here for the type of experiment. Then determine the parameters according to the requirements of our national standard. Modify. Click on the home page after modification. Point test interface. Reset key point OK. Next, we demonstrate tare loading. We load it like a tensile test. First, the sample must be placed in the middle of the furniture. The mouth we want to test. Try to center it in the middle of this gauge. After the sample is served, we will check the 0. Click Run again. After the experiment is over, we can see it here. The current experimental data. Then print the report. Click on the home page and then click on the report. Then click Report Settings. Confirm one of our experimental information. Confirm the experimental information. Then we print. Click to print the report. Next, we demonstrate calibration. For calibration, we need to click to rise first. We take a 200 grams weight, or a kilogram of weight. Let this be furnished. Just rise to higher than this weight. After rising to a position where the weight can be placed, we click Stop. Need to click 0. After clicking to clear, we hang up the weight. We can tie the weight with a cotton thread. Then clamp it through the upper jig. Use hands after clamping. Lift this weight. Keep it from shaking. After we hang up the weights, look at the current force value. We are now 1 kilogram. That corresponds to a force of 9.8 cattle. If our force value is not 9.8 cattle, we need to make a correction. Click on the home page and then click on the calibration interface. The password is 1598. After entering the calibration interface, and then we mainly correct for this excitation coefficient. So if you use a kilogram of weight to call it out, it is smaller than the standard value of 9.8 twists. Then we need to calibrate. What about calibration? Divide the actual force value by the current real-time force value. Multiply that by this force correction factor. So after we figure it out, remove the weight first. It has a force correction factor of 1.0. Then we change it to 1.0. After changing the force coefficient, then we check the 0 first. After clicking clear, we put the weights back on. We can all check it at this time. This real-time force value is 9.8 cattle. That is correct. Next, I will demonstrate the connection operation of the computer. There is a communication port on the back of the instrument. This communication cable is used to connect to the computer. It is used when operating with software. The communication cable is plugged in here. What about the other end? Just plug it into the USB of the computer. Next, we demonstrate the software installation. We plug the matching USB stick into the computer. Double-click to open. Find our folder. Then copy it. Copy to your computer's local disk. You can create a folder. Then copy the software on the USB stick. Quit our USB stick first. Then we open the software. After opening the software, we are the first to install this software. After confirming the installation, we also need to install this serial port driver. Let's put it first. Unzip it. After unzipping it, we open the driver software. Install. Click to install. The installation is successful. And then we come back to this. Install the third one. Then we will install the USB driver. Unzip it first. Click Install after unzipping it. Choose this. Double-click to install, according to the prompt. Complete. Return to the package. Extract our software. Open the software. Select one of our program software. You can send it to the desktop shortcut. Then we open the software. Our initial password is 123,456. Click to log in. Click Newsletter. Click Serial Port Settings. Confirm this string of slogans. Then click OK. So where is our serial port determined? We can click the computer with the right mouse button. Then click Manage. Click Facility Management. Click on the port again. So this one is one of our communication serial ports. It is possible that this COM port is COM3. Then we are directly in the communication settings of the software. Select if it is COM3, select COM3. Then ours is COM18, so choose COM18 to confirm. Then click Serial Connect. After the communication, there will be real-time display data jumping. After we communicate with the computer, there will be a prompt box. It prompts that the host computer has been connected to control. I'm going to show you how the software works. Then first we click Settings. After clicking Settings, this is one of our settings interfaces. The general default is to use historical control. Here, the program control can be filled in 0. Judge that we choose automatic by default. You can also return manually. If we return, it will be after our experiment is over. It will automatically return to origin. If it is manual, we need to manually click to descend. Generally, we choose automatic by default. Then the width is confirmed. Thickness gauge. These parameters can be set according to our national standard. Force unit, we usually choose cattle. After entering the parameters, click OK. Then serve the sample. After serving the sample, we need to click Reset. Click to run. After the experiment is over, we need to wait until this force value automatically returns to 0. We can make a modification to this curve. Easy to view. You can set the curve. Then x and y have a minimum and a maximum. We can do this by looking at one of our coordinates. Modify. X is our direction. Then the smallest is 0. Max, we are now 80. So let's change it to 80 first. Then the y-axis minimum also starts from 0. We observe it at our highest. The highest is about 60. Then the maximum can be changed to 60 here. Then click OK. At this point, our graph can be enlarged. After the experiment is over, we can click Save Experimental Data again. Click OK. Then there is a test result interface. You can see all our data in this one. If we do experiments, the national standard cannot be lower than 5 groups. 5 experiments. His curve color is different. So let me show you. We have 2 colors in our graph. There is one of your word counts above this, represents a color. Then generate a report. After generating the report, according to one of our experiments, fill in the letterhead information into this. There is a save path after filling it out. We can click the button on the right. Then find the one you need to save, folder, or a location that needs to be saved. Then click Save. Click OK again. At this time, we have an experimental report. Then print it again. We explain a database of this software path with one of our data saves. First, we right-click on the software. Open folder location. Then what about a file we need to back up? It's this GBL.PD. This file is one of our databases. Reports folder. It is the experimental report folder we export by default.